Hello. Can you guys hear me at the end? Cool. Thanks. Great. So, welcome to ATC302 session. Today we are going to talk about life lessons, and I'll talk about my life journey. So, my superpower is like I can sleep anywhere, anytime, in any position. So, like standing, I can sleep. Literally, I was coming with these guys from MGM to here, and I was sleeping in the bus. So that's my superpower. Let's talk about Vijay's superpower. No? Okay, let's talk about digital advertising business. In today's session, we are going to talk about how we implemented Google DoubleClick campaign data using few AWS services. We did the machine learning part and also the data transformation part. With me today, we have Abraham from Amazon A9 team, Vijay, he is solution builder working in solution architect team, and myself, Shashi, working in AWS as well. So in today's world, we are working with huge data set. We accumulate so much of the data in few weeks, if not months, and we are talking in petabytes nowadays. And in digital advertising, we are proud to play with such data set, right? And machine learning has not been new in this organization. In digital advertising, we have been using as a developer, a data scientist. Whenever we go to any slot machine, we try to figure out the probability of winning and then try to win from that, and sometime we do. So similarly, you might be also using few processes or the ways of actually running the digital advertising, like lookalike model, cost optimization, campaign optimization. But when you are starting in digital advertising world with machine learning part, right? Like let's suppose you are running a lot of big data core concepts, but if you are getting in the machine learning part, there are few challenges initially. Few are around infrastructure, like scaling. Can you scale up or down based on your requirement? Then processing time, how fast can you get the outcome? Because businesses don't want to wait for the outcome, and neither we do want to wait and look at our machine and it's processing. So that one part, and then second part is also around the skill set itself. If we are pretty good at what we do, but suddenly there is a new technology we need to use, are we good at that? Do we need to start learning on that just to get our day job to be done? AWS helps simplifies those challenges. With advent of AWS cloud computing or cloud computing in general, we got to touch such a huge compute resources, memory power, right? Now we can process huge amount of data. And now when we start machine learning to start actually process these data, AWS can help with the core concepts like scaling. You can easily scale up or down based on the requirement, how fast you want to actually get your outcome to be done, how fast you want to process the data. You can easily scale up based on that. And whenever you need to actually save cost, you go ahead and scale down within few minutes, if not seconds. Then other part of it is again the skill set. With so many AWS managed services, you don't need to start learning from scratch everything what you need to do for the new technology you are actually going to adopt. You can use these managed services, and with those managed services, you will be able to get started right away. It's always circle. With this, what we are trying is first it starts from the business understanding in the data analysis part. Once we have some understanding that this is what exactly we want to do, we go ahead and understand the data first. Data is understood. Next, we prepare the data, which is like transformation piece, exploring the data. Once that part is done, then you start building your training part. You are training your data, getting the evaluation, getting the performance. You don't like the performance. You go back and train more, you add more features. Once you have done that, again, check the performance. When you find it pretty well, you go ahead next and deploy it, and you get the outcome and businesses are happy. In today's session, we are going to go through 2 demos around data analysis and data transformation part. We will use all the AWS services which is related to these 2 demo. And then I will hand over to Abraham from Amazon A9, who will take us to the lookalike modeling he did using few AWS services. Let's understand the workflow. We are going to work with 2 data sets. One is activity table and another is impression. Activity, I mean, you guys must be already aware, but just to give introduction. With activity, the data which is user is already converted. That means he or she has already purchased, versus impression table, which is more like all the users who have browsed the session and the images were placed on those sessions. So impression table in general will be huge compared to what you will get in activity table. The data transformation piece we want to do is CSV to Parquet, because all the data we are getting in CSV format initially. And then we go deeper in the machine learning aspect. What do we want to do in the workflow? Also about the data side, the activity table and impression table, we are going to use very few specific columns, because you know that there are like hundreds of columns in the activity or impression table. So we'll use few generic ones like activity ID, user ID, site ID, and then we'll have few specifics to the features like browser ID, platform ID, or operating system ID. So this is the workflow looks like. We are going to go for the data transformation piece, where we will actually do the transformation, exploration, and also visualization. And then we will have the second workflow in which we will go ahead and do the data feature engineering. Let's dive deeper in the first one now. In the first one, our assumption is that your all data is coming from all the whole world, like from ad exchanges, your pods, and you are streaming all those data in log format for activity and impression, and ending up at central location, in our case, say S3 bucket. Once you have all the data at the S3 bucket, that is where we take it from there, right? CSV format, that's what we have in the S3 bucket. Your data is time series format. We are going to use AWS Glue. AWS Glue is ETL, extract, transform, load, fully managed service, which we will use to do the transformation piece. Once we have that, we go ahead and explore the data using AWS Athena, which is SQL query interface where you can run your all interesting and favorite SQL queries. And then at the end, we will use Quicksight to actually go ahead and visualize the data. And that will also be helpful to business intelligence, business analyst team to create a lot of reports, share it with your customer, vendors, or even internal teams. So let's switch to the demo. So this is the first demo. And we are trying to go live, so if it doesn't work, we have backup plan. So we are starting with AWS Glue. As I said, we are assuming that your whole data set is already coming to S3 bucket. In central location, you might be using, say, AWS Kinesis to stream all the data. And once you have that, we start using Glue for the next stage. At the left side, you will see there are multiple sections under AWS Glue. The first part is data catalog. Data catalog actually helps to create and automatically creates the metadata and the indices of your data. How will it do it? It will actually do it through crawler. So we'll create a crawler which will crawl through your source data and understand the data. Even if you are changing the data set, it can actually understand that and update that too. And it will create the indices for you. You don't have to go ahead and do it. So let's actually go ahead and try to create a crawler, which will help us to create the table as well, right, in the database under data catalog. Crawler name. So there are just like 5-6 steps, pretty easy ones. We'll just walk through a few steps. This is where we actually tell where is the data stored. So this is the data source we are going to check. So with the name you can understand it's a synthetic data. So this is the source where we have the data where the crawler will go ahead and crawl. It's asking if you need to add more data store. In our case, we'll just go with none. Next. Yeah. Here, AWS Glue needs to talk to S3 bucket, right? So you have to give permission for AWS Glue to talk to S3. So for that, you have to have an IAM role. In our case, we already created that role, and we'll go with that next. This is interesting. The crawler, you can assign how frequently you want this crawler to run and refresh the data and push it in a tabular format. So you can go hourly, daily, weekly, however your requirement is in the business. Just for this one, we'll go with run on demand. And now we actually create the table under the database. So we have the database already created. We add prefix just to recognize what the actually table will be, and that's it, done. So go ahead and close it. We already have this following exact same steps. One of these two crawler. Can you hover on the crawler just to show which one? Yeah, CSV. So this is the one which we created with exactly same process, no change. So once we have that, it gives us a table which is in CSV format, like it's reading the CSV data. But really we need to do the transformation piece. We want to transform the data from CSV to Parquet so that it will be easily readable with the distributed system. So for that, you have to actually go for jobs, and that's what it will transform. So in our case, we'll create a job. Go ahead and create add job. Again, you have to give a role, because it will, in our case, we are fetching the data from S3 bucket and we are pushing it back as well as a data target. So in our case, we go ahead and select the, so in this case, we have to do script and temporary directory where it will actually go ahead and do its transformation piece temporarily, and the script directory. Next, so choose the CSV one. Great. Here you are creating the target. Where do you want to push it back? So in our case, we'll go ahead and select S3, and the format we want to select is Parquet. Right, and the target path wherever you want in the S3 side. Next, you will see the mapping. So the first magic part, that crawler actually created the indices, and now it is asking, do you want mapping one-on-one? If just for the demo, we'll go with one-on-one, but this is where you can actually edit it as well if you want to, and do next. And that's it. Now you have a job which can transform the data from CSV to Parquet. Close. And we created this job just to show you guys here. Edit. So remember when I was actually talking about that if you have to start a new technology, you have to learn a lot, add new skill set in your team. So if you are not like working with PySpark, say, and if you are not doing data transformation this way, AWS Glue is helping to do that. So what we did behind the scene, it actually went ahead and created automatically a script for us in PySpark format, which you can understand, edit if you want, or if you just wanted to transform the data from CSV to Parquet, you could have done that. So this is pretty cool. I like that because I don't know PySpark. So now close it, and we have that job running. Now can you go back to tables? We have second table, which is actually once the transformation is done, it's in Parquet format in S3 bucket somewhere. So I have to create another crawler which will crawl through the data of Parquet and create the table. And that's what we did here, and we have the table ready. So if you want to visualize this data and you really want to use SQL query, so there is a direct connection from Glue to Athena. So this is magic. What it happens here is Athena can talk to Glue data catalog directly. Now you have the database which you created in the Glue part is directly showing up here, and now you can start running queries. So the transformation has happened. You have the interface, run your favorite SQL queries here and explore the data as much as you can. So Vijay ran like first few 10 columns, 10 rows just to show it. Second part is if you want to create another table through AWS Athena. Can you go back in Athena? So you have an option, create table, and now we have applied that you can automatically create a table in the Glue catalog. And this, if he clicks, it will go back to the crawler section of AWS Glue, and you can create the table. So pretty well interconnected between the data transformation piece and the SQL query interface piece. So now we have done the transformation, we have done the exploration. Next, we want to actually visualize. We want to create a report or something. For that, we are going to use Quicksight. So we'll create a new analysis, a new data set. And here, you are able to select Athena. So now it's fully connected from Glue to Athena to Quicksight. So Quicksight is able to talk to the same table we created inside the AWS Glue. And if I want to explore the data, I want to actually edit the script directly inside the Quicksight itself and don't go back and forth between Athena, I can do that. So edit. Yeah, so table left side. So this gives me option to edit and run the SQL query in the Quicksight itself. So I can do my visualization, customize it however I want. So this is just for the demo part, like you have an interface here as well. So can you go back to AWS Quicksight? Yeah. So I created one similar to that. My visualization is actually showing 3 fields. One is user ID, site ID, and third is I'm grouping by site ID, and every if you hover on one, yeah. So what it is trying to show is that I have a glasses and I did not put it. So the site ID is 1573318, has so many users sorted down and showing how many times a certain user visited this site ID for the given period for the data. So if I have, like in my case, I have data for 30 days, it's showing first user ID actually visited 27 times on this site. So again, this is just an example. You can do whatever you want and create a lot of good reports for your team and vendors. Great, so that's the part for the visualization. Switch to the presentation. Thanks, Vijay. So to summarize what we did, we actually first assumed that you have all the data coming in S3 bucket and central location. Once you have that, we used AWS Glue for the transformation piece from CSV to Parquet. Then we explored through SQL query on AWS Athena, and then we used Quicksight for reporting purposes. Awesome. Now let's get in the data feature engineering. This is the second piece. For this, the architecture we are using is, again, starting from S3, where you have raw data in CSV format for activity table and impression table. This time, we are going to do the transformation piece with EMR Spark cluster. Once we have done that, we get the data transformed, which is readily available for machine learning library of Spark, which we can utilize for the machine learning features. We also have Jupyter Notebook, which is actually not available on EMR Spark cluster natively. You have Zeppelin for sure, but just so we could use Jupyter Notebook, we integrated Jupyter Notebook with the EMR Spark cluster. And Vijay actually helped to create this reference architecture. Vijay, do you want to talk about like what you did behind the scene?
Sure. The solution that we are building is having an EMR cluster deployed on a private subnet and having Jupyter integrated with EMR cluster, which is not readily or natively available at the moment. And then we have the ALB that's sitting on top of the EMR cluster so that we do not have that port forwarding or Foxy proxy to be done. And secondly, we have Spark ML, which has a very robust integration of algorithms for model training. So we are having Spark ML deployed on an EMR cluster. We are running this complete solution. So let's go ahead with the demo.
Yeah. So before we jump to demo, one question you may ask is why are you using sometimes AWS Glue, sometimes EMR Spark cluster to do same thing? Both has its own advantages. With EMR Spark cluster, you get to control the cluster size. You can scale up or scale down however you want. It has Spark, so it has a lot of open source goodies like machine learning in my case. And with AWS Glue, it's fully automated service. You could see that just with few clicks, me not knowing PySpark could easily start transformation from CSV to Parquet, and I can have a cron job running for me, and I don't have to worry. So both has its own good. In this case, we went with Spark cluster. Okay, let's actually go to demo.
Yeah. All right.
For the demo, Vijay built a CloudFormation script, which he actually talked about, that how the components look like. And he has this link which is going for the ALB, and this ALB points to Jupyter Notebook. And this Jupyter Notebook is secured through password, which is saved. That's why you didn't see it, but really it's secured. So this is the notebook we have. So let's actually talk about what are we trying to do here with the machine learning piece. First and foremost, this is synthetic data we are working on. We tried to make it as real as possible, but it's really synthetic data. We have activity table and impression table, both are purely synthetic data. In the summary, I just wanted to let you guys know before I go stepwise. Our idea is to actually understand the user behavior. So user is first, like we are creating different features. Say we want to understand certain, like what browser IDs users are preferring, say Chrome versus Internet Explorer or Firefox. Similarly, we want to understand what operating system ID user is preferring, like iOS or Windows operating system. So, and then we have another feature based on ad ID. So we just combine all these and evaluate. Based on the evaluation, whatever performance we get, we work on that performance on the test data set. And the performance will help us to create the subset of the main data set, which will actually be good, and at least we hope it will be good for our next campaign, so that we are getting better conversion rate, and that's our plan. We followed 5 steps after the transformation. First was we did featureization. Then we went ahead and split the data in 2 pieces, test data and train data. We actually did the orchestration for train data. We did the model training on the train data. Once the training has been done, we went towards the test data to evaluate the performance, and then we used few graphs to understand the performance better. So let's actually go through the whole step. So Vijay is actually running this live and hoping it will work, otherwise we have backup plan. So the data set size is like 15 gig for impression table, and activity table is few megabytes. So the first part is really loading the data in the Spark memory for the activity and impression table. Once we load the data in the memory, we go ahead and do some cleanup work. With cleanup, I mean like deduplication of the data, removing all the garbage which is like meaningless in the set. Once we have the cleanup part done, then we actually dive. First part we are doing is featureization. We used one hot encoder for that, which is going to help us to convert column of indices to column of vectors. Once we have done that, we actually go ahead and split the data in test and train. Test and train data, why? Because we are going to do the model training on the train data, and then we will evaluate the performance on the test data. So first we will analyze the data separation. We used histogram for that. Let me go closer. Train. So the train data is showing, the histogram is showing converted versus non-converted users split, and then similarly it is showing for test data, converted versus non-converted. So test looks good. Let's go ahead and do the actual work, model training. For that, we are going to use logic regression model. We set up the pipeline. Like I said, this is the orchestration part. Once we have done that, we go ahead and train the data. Training has happened. Did it happen?
Yes.
Yes, this looks good. So yeah, it's working so far. Now we'll understand the performance. First, let's clear all our confusion using confusion metrics. So can you scroll down to the confusion metrics? Yeah, so the true positive rate is looking 1909 is the value, what we are getting. Again, this is synthetic data, so with real world, I don't know how the data will look like or the result will look like. So now let's go for the compute, and we are using AUC with the binary classifier. So the output we are getting here is 0.67, which is like 67%. And Abraham was saying, who has in-depth experience with the real data set, that this looks amazing. I'm like, okay. So once we have this 0.67, we actually go ahead and start doing graphs actually. So the graph we are first creating is ROC. In the ROC, we want to actually, the perfect graph would be if we go closer to 1.2, which is like left top, right? So towards the true positive rate, that will give us the perfect result. But in our case, we are based on 0.67 result, we are getting the graph towards the true positive rate, but on an average. Once we have that, we go for the precision recall. With the precision recall, if you go down, yeah, the graph part, we are seeing the precision side, that's the relevant data. How much relevant data we actually captured, and out of that, how much data we retrieved from the relevant data. And the result on an average is looking pretty awesome, which is 0.85. Again, result will differ in your own data set. This is just what we got. So let's also talk about why did we use EMR Spark part. The Spark part actually helped, you could see that we could create graphs, understand the performance in many different ways. So Spark helped us to do that. If you guys are data scientists, you love Python, you can run your Python script, so you can use PySpark for that. If you like sklearn module, you can go ahead and use a sklearn module. So open source community is so good with Spark. I don't have to tell a lot about it, you guys are already aware. It helps a lot to go with the Spark in this case. Once we are done with this, we have the good result. We have the better data set, which is the subset of the bigger set, which we are going to use for our next campaign. And we are hoping we will have better conversion and businesses will be happy. Cool, that's it. And then we just clean up the memory of Spark. That was the last step to start our new job if we need to. Great. Thanks. Can we switch? Thanks. So now we are back to demo. The presentation.
All right.
So
Thanks.
In summary, what we did, once we had the S3 bucket with all the data in raw format for activity and impression table, we went ahead and used EMR Spark cluster for the data feature engineering with the machine learning library. And then we use Jupyter Notebook to run all the steps. And I am hoping the data scientist in the middle will love to see the notebooks. Now I will hand over to Abraham, who will walk us through how he used few AWS services to create lookalike model.
Yeah, thank you. Yes, I'm Abraham. I'm from A9, which is an Amazon company in Palo Alto, and we work on advertising, in particular the science side of advertising. So we've seen today how different AWS services can be used to do lots of interesting things in advertising. And I'm going to talk about one aspect, which is targeting. This equation is pretty much everything you need to know about advertising. Has all the major pieces in there. So every ad server you'll ever see works something like this. First, we take a list of ads that are eligible for a given request. I denote this by A of X, where X is the request. And then we calculate an expected value. That's where the B function comes in. That expected value, then we select the one that has the highest value, and then we bid. It's a little bit simplified, but these are the main components of an ad targeting system. You've got bidding, which is something that computes the expected value. Then you have ad selection. And before you can even get started with all that, you have targeting. And so if you have a DoubleClick Bid Manager campaign, one of the things you have the most control is the targeting. How you set up that campaign, how you do the targeting. And so in order to understand what targeting is, we're going to dive in a little bit deeper into what that looks like. So I like to think of targeting as a set of if-then rules or triggers. You might think of it as if a particular function gets evaluated on the request or the context and that returns true, then this ad is eligible to be shown. So then that function we saw earlier of A of X would be all the ads that are eligible to be shown for the user. So that's all the triggers that return true. Now, there are many different ways to do ad targeting. We'll talk about some of the major ones here. The first is what you'd call state-based ad targeting, and that's where demographics and geography tend to come in. These are properties of the user that don't change very often. They're very popular in display ads. The next is behavior-based targeting, which tends to look at what people have done in the past. Retargeting is a great example. You see an ad on Amazon, and for the next month, you're going to be seeing that ad wherever you go. I'm not in charge of that part of the business. So then, beyond behavior that looked at the past data, the context looks at what's happening right now. So at this moment, you might be sitting in a room looking at your phone, playing a game, and not paying attention to me, and that might be very useful for advertising. Or later, you might be jogging in the park at night and a little bit creeped out about us showing you ads like that. But that's an example of context-based targeting. And the next one doesn't look at the past, it doesn't look at the present, it looks at the future, which is predictive-based targeting. So that tells us, what are we going to do? Are we going to buy a product in the future? Are we likely to be a high-value customer or strike it big in the casino and be a high roller? These are all things that haven't happened yet, but we can predict them. And the way I like to look at predictive targeting is by these boxes here. So imagine that the entire universe of users who can see ads is the big box. The smaller box, which I call the targetable population, are those users you can actually show an ad to. Not everybody's seeing ads right now. Not everybody's in your target customer base. So a subset of these can actually see ads. Now, some of the users you actually care about are what we'll call the target users. Some of them you can show ads to, some of them you can't. But we actually ran an ad campaign and we found the reached users. Those are the users that saw the ads. So right now, there isn't a lot of overlap between these users. And over the process of lookalike modeling and predictive targeting, we'd like to take the users we can actually reach through targeting and match it to the target users. And we'll talk a little bit about how that works. So lookalike modeling, which is the subject of our discussion now, is a form of predictive targeting. And sometimes the term can be confusing to people because there's actually two different ways to do it. There's one which is called similarity-based targeting, which is what most people think of when they hear the term lookalike modeling because users look like other users. The challenge with similarity-based targeting is no one knows how to define similarity. That could be a problem. And if we come up with a definition, how does that translate into an advertiser's performance? Just because two users doing the same thing in the past, how does that mean that they're going to buy the same product in the future? So it works great if you just have a target list of customers that you don't really know why they're important, but you think they're important. Classification-based lookalike modeling now talks about performance. So now the users perform like the target users. We can then solve for the direct advertiser problem, like conversions. This can then be easily translated into revenue and the budget that you'll be interested in, and we can compute ROI based on the model. And this is a great fit for activities that we see in the DoubleClick Bid Manager data, such as purchases, leads, and signups, and other sorts of things, usually targeted by pixels. So now our predictive targeting looks a lot like the trigger that we talked about before. So instead of saying, this user did or did not do something, we have a probability. We look at the probability that the user is going to take this action in some number of days in the future. And if that's bigger than a specific threshold, we're going to show the ad. So that's a fairly complicated statement, so we're going to break down all the different pieces. The user then refers to a representation. We have to define some way of looking at users. We saw earlier about different kinds of features that we could define. That's an example of a representation. The next is our attribution window, which is how long in the future are we going to wait? If we show this ad to a user and it takes him 100 days to convert, that's not necessarily a great use of our advertising budget, but if he converts in the next 5 to 7 days, that might not be so bad. And then the probability is where the classifier comes in. So we're going to use an ML model to predict how likely the user is going to respond. And finally, there's the threshold. The threshold is our main control that gives us the ability to have a larger budget or a smaller budget. It gives us a way to rank order all of the users based on that score and put our budget where it does the most good. So we've seen a couple of examples of data pipelines, and I'm going to show 2 here. The first is the training data pipeline, and that takes data from DoubleClick Bid Manager through S3, runs through EMR into something similar to what we saw earlier, some basic machine learning models. And then that can run, say, weekly, gives you finally a model that you can reuse in the future. Then there is a scoring pipeline that takes that same data that might come in today, scores the model against all the users, and comes up with a list that then can be uploaded into your favorite DSP. And this is how you can create your own custom user segments. So here's an example of how users could be represented. This is an anonymized data set. It's not a real data set. But you can see all the major fields are there. And you might be surprised to learn that there aren't that many fields present. I mean, you might think that we know lots of things, but most of what we know comes from browser, OS, site, time of day, and there's lots of different combinations of that. We're going to group them, all of these records then by user ID, which is the one thing that we have in common here. And then once we do that, we're going to generate a simple representation. I call it a bag of events, similar to a bag of words that you may have heard about in other areas. Here's a quick code snippet of how to do this in PySpark. We're just going to group by user ID, and that's it. Not super complicated there. And now we're in a position, once we have all the data grouped by user ID, we can start to build our training examples for our model. And we're going to split up our data into 3 distinct periods. The first is the training period. That's the period of time relative to the time that the actual event occurs. So let's say that you were to convert in an ad, let's say yesterday, you became a converter, and so we're going to look, say, n days in the past and say, how long ago do we have history for you? Maybe we have a month's worth of history. So that day minus a month is our training period. Then we have the target period. That's where the conversion window comes in to say, well, you converted today, but I'm going to look back and say the next 7 days and see if you converted on any particular ad. And now we can have predict from the training period into the targeting period. There's a section in the middle that's called the blind period. Now this is an important part of your modeling process because what tends to happen is that there's a latency between the time that the user sees the ad and can convert, but between that time and the time that you can actually get the data, run it through EMR, generate the models, score the new users, upload them to an ad system, and have the ads shown again, that could be a while. A day or two, maybe a few days. It could be a long time. That has to be accounted for in your model, because if you're saying, well, whatever you did 5 minutes ago was super useful for predicting ad performance, I can't do anything about that because it takes me a day to upload a user list. So when we build our classification model, we're going to create basically positive and negative examples. So one easy way to define those is that if a user had the activity, they're positive, and if they didn't have the activity, they're negative. There are lots of different nuances to how you can define the target labels in here, and we could talk about those after the session if you're interested. So here's the quick code snippet. The way I like to generate this data is I first generate the target labels, which could be much smaller and tend to have the activities or clicks associated with them. And then I join them with the user data and then do the feature extraction at that time. This cuts down the data set for training. It makes it really efficient. Once we've done all of our training, you saw earlier about the precision recall curve that we saw. This is a little bit different. This is a reach and precision curve. The main difference here is that reach is different from recall. And reach is the number of users you expect to reach in your ad campaign. Now, Those of you paying attention realize that reach and false positive are the same thing. So you could call it a false positive curve. But if you take your ad budget and you take the total number of users, because this is a user-based model, multiply that by a frequency cap and add in the average CPM for your ad campaign, you can kind of get at a number that's close to the total budget size. And so that's where that threshold that we talked about in the beginning comes in. The threshold gives you a cut point on the reach. So now you can use that threshold to decide whether you want to spend more or less to show your ads. We're trying to give you the best users for the budget that you have. So if you actually wanted to work on this and build your own lookalike models, it might be a good idea to run some basic data checks. The first thing is, do the users in your data set have enough history to make this thing even make sense? And so the kind of plot you can do here is to say, well, how many different days of history do I have for a given user? What you're looking for in this plot is a curve that sort of goes up towards the end. That means that users keep on coming back to your site. You keep seeing them more and more often. If all your users started at the very beginning, I don't know if you can see that, but there's a peak at 0 days here. These are users that tend not to save their cookies, and so that's not very helpful for lookalike modeling. The next check is all those features that we saw in the representation section, how many of them are there? How many different browsers are there? How many different operating systems, which is basically all we know about users, and different sites. And you can see a nice distribution here. This is on a sample data set. And the same thing for sites and ads. So one feature that people don't always pay attention to in lookalike modeling is the previous ads that users have seen, because there's actually a lot of information and targeting on other ads. So having the historical ads people saw can be helpful too. Right? So now that we've calculated all those different counts of things, we're in a good position to start training our models. We don't want something with a huge number of cardinality, and you don't want something with a little cardinality. So once we've trained all that, we draw our precision versus reach curve. Now, those of you who can see the numbers over here will see that the precision is actually very bad, unlike the synthetic data set that was presented earlier that had amazing precision. So this is a much more realistic data set. The precision tends to be very bad in advertising. I'm sorry. But the point is that we can now order our users a little bit better than random. So when we started this ad campaign, we targeted 100% of users, and that gets us the precision at the very far end of this plot, which is really bad. But now with our lookalike model, we can score our users, we can rank them, we can pick the top ones, and so if we were to just say, concentrate our budget from 7 million users to the top 10%, we could spend our budget more efficiently, and we'd get 3 times higher precision, which is probably a good thing. So we've seen how the various services in AWS can help with lookalike modeling. One is S3, which is mostly where we keep all the data, and that's very helpful. And the second thing is EMR. We've run all of our data processing on EMR using PySpark and technologies. We can put those data pipelines into AWS Data Pipeline, which will run them every day or every week as needed. So how could we make this better? Well, you've seen a lot of different extensions of using AWS today. One way we can do this is we can make this better using EC2. In a sense, we could build our own bidder. So instead of having to rely on DoubleClick Bid Manager to run your ad campaigns, you can build your own bidder, and I believe there was a talk earlier today about how to do that. The next part is Kinesis. We can get real-time streaming data going through this thing and start to build our targeting segments and update our models in real time. We can then use SNS to listen for different conversions that are going to happen. And we can respond as soon as somebody buys something, we can stop targeting them with the same ad or other stuff. And finally, there's DynamoDB, where we can put all this data into a giant lookup table and get data as fast as we need it. So I'll leave it now to Sashi.
Thanks, Agrahm. So before you walk back, I have a question. Thanks. So do you have a blog post coming around this, which you want to share?
Yeah, that's right. We'll be working on a blog post that covers how to do all of this stuff. It's worked on, and it's going to be launched soon.
Nice. And also I heard like you called out that you can actually do the same time series data based on the users, which also pretty good, right? For like if you keep adding your time series data based on the user ID, that actually gives a lot of benefit when you are running a lot of different models.
Yeah.
Great. So to learn more, you can go to the link we have provided at the below. We have all the resources there, and we are going to add more. There is a contact us link as well under that page, where you can go ahead and click to get a deep dive session with our team, and even request workshop where we can go through the whole process we actually demoed today. And Vijay and his team is creating one-click solution as well, which you can deploy in your environment and play with the synthetic data, or if you want, you can switch it to the real live data set. So that will be coming soon. So that's all we had. How much time do we have? 15 minutes, yeah. So we can take questions if you guys have any.